Reteaching, solving equations. Now this first one, it's gonna be a doozy. The reason I say that is because I have multiple angles and it's a 4 and I have to solve between 0 to 2 pi. It wouldn't be as bad if I did all. Make sure that when you're doing these problems, you're reading the question carefully, knowing if you have to solve in between the interval or all. Interval has exact answers in radians. In between, or all of them should have an n because it's saying any rotation. First thing I have to do is get my cosine by itself. So I have cosine 4x is equal to negative 1/2. I'm going to draw my picture. All sad turtles. So it's adjacent over my hypotenuse. So now this is just to figure out what my reference angle is. So here's my reference angle. It's across from my square root 3. So my reference angle would be 60 degrees. So now first find out my first rotation. So I'm going to write the 4x so I remember. 4x is equal to my first rotation. This angle right here would be 2 pi over 3. My second angle right here would be 4 pi over 3. That's my first rotation. So then I have to keep on adding 2 pi until I have 4 rotations. I have 2 pi over 3. So I'm basically finding my reference angle. Not reference angle. My coterminal angles. I don't know if I'm using the terminology right. I'm going to add 2 pi. 2 pi would be the same thing as 6 pi over 3 plus 6 pi over 3. If I add those two together, I would get 8 pi over 3. And I'd also get 10 pi over 3. That's my second rotation. I have to add 6 pi again over 3 plus 6 pi again over 3. If I add those two together, I get 14 pi over 3 and 16 pi over 3. And then I have to add it again. So I have 4 rotations. 4 rotations. So my final one would be 20 pi over 3 and 22 pi over 3. So again, just to review, this was in 1 rotation, then I went around the circle again, 2, went around the circle again, 3, went around the circle again, 4, because of this right here. This is saying I need 4 rotations. So I'm dealing with all of these problems. So now here are my 8 answers, so now they're equal to my 4x. So remember now I have to multiply this side by 1/4, and I have to multiply this whole thing. So each and every answer by 1/4. You have to multiply each one, and you should simplify those answers. So I'm going to write them over here, and I'll bring that back. My actual final answers then would be x is equal to, ta-da! Again, if you can simplify the fraction, you should simplify the fraction. If you're wondering how I got something, I multiply each one of these by 1/4. So like here, when I multiplied this one to get this answer, I simplified 20 pi over 12. I can simplify because both of those are divisible by 4. So that simplified right here to 5 pi over 3. Okay, next problem. Move this stuff out of there. Boop. First thing I'm going to do here is move over the tangent. The reason I'm moving over that tangent is because I know that once I move that over, I'll be able to factor it out. So I factor out that tangent. So I have tangent x sine squared, my handwriting is terrible, minus 1 equals 0. Set both of those equal to 0. So tangent x equals 0, and sine squared minus 1 equals 0. Now tangent equals 0, that's the tricky one. If tangent ever equals 0, you want to switch it to sine over cosine. Tangent can be 1, cannot be 0. So that's the only time when you want to switch it to sine over cosine. So if I move this over a little bit, now all I'm really looking at is the sine, because if I were to get rid of this division, multiply both sides by cosine, 0 times cosine is 0. So I'm just focusing on sine of x is equal to 0. So that's one of my answers. And Sine squared minus 1, that's the same thing as sine x. Take the square root of a positive 1 is plus or minus 1. So if I draw up my graph to help me figure this out. Whoops, it's easy. Sine is equal to positive and negative 1. That would give me my x. Oops, sorry. Sine is equal to positive, negative 1. Sine is my y value. So here's where y is positive 1. Here's where y is negative 1. So 0, positive 1, 0, negative 1. And I have sine is equal to 0. So that's my y value again. So positive 1, 0, negative 1, 0. So this first one, this is sine is equal to 0. Here's sine equals positive 1, sine equals negative 1. So my final answer would be all of these, this angle, this angle, this angle, and this angle. So you have to know those angles. That's something you just gotta know. So of my 4 answers here, x is equal to 0, that's that first angle, pi over 2, that's my second angle, or just pi, third angle, and 3 pi over 2. Those are my 4 answers for that second problem. Third problem. Moving on up to the side. So already I can factor out a sine. So I have sine on the outside. That's leaving sine x minus 1. Set both of those equal to 0. So I'm dealing with sine x equals 0 and sine x equals 1. Because I'm already adding over the 1 right there. That's where I get positive 1. Draw my picture. So sine is 0. Sine is your y value. So your y is 0. It's right here and right here. 1, 0, negative 1, 0. I also have sine as 1, so this is the only point right up here. It's kind of like the last problem, but not exactly. So sine is 1, 0, 1. So my 3 answers here would be, actually first is 0. That's this first one. I have pi over 2. That's the second one. And I have pi. That's the third one. So those are my 3 answers for question number 3. And question number 4, I'm going to zoom in a little. Secant, going to change that to 1 over cosine x is equal to negative 2. So I'm going to flip both of those sides. Cosine x is equal to negative 1/2. So drawing my picture, all sad, so cosine would be negative here, and turtles, so this is adjacent over my hypotenuse. I mean square root 3 over here, so my reference angle is 60 degrees. So I'm dealing with this first angle. That first angle would be 2 pi over 3. And I'm dealing with this second angle. That second angle is 4 pi. 4 pi over 3. This first one I have to factor. If you have trouble factoring, it's the same thing as this. It's the same type of factoring as if I had this problem right here. I have to factor that. Here it is factored. If you ever want to check your work, you want to make sure that your outsides and insides, if I multiply those together, are equal to, added together, this. So this would give me a negative 2 cosine, negative 2 cosine, and if I add those together, I get negative 4. One thing I noticed, they're the exact same thing. So really I'm only going to have to use one of the parentheses. So I'm going to have 2 cosine x minus 1 equals 0. If I solve for that, that's cosine x is equal to 1/2. So that's the only picture that I'm drawing. So it's positive, all turtles cry. I have my adjacent and my hypotenuse. So across from it would be my square root 3. So my angles here are 60 degrees. Now again, this is where you want to check. In between these two terminal sides is 120. On this side, it would be 240. So they cannot be combined for my equations. So I'm just going to have 2 equations. My first angle, 60 degrees, that's the same thing as pi over 3. Remember, since I want all solutions, no matter how many times you go around that circle, and one circle is 2 pi, I have to have the n. My second angle, so this angle right here, so this angle is 300. And if you were to write that in radians, it would be 5 pi over 3. And again, you have to add on every circle that you might go around, positive or negative. So that would be my answer for question number 5. Question number 6. So I'm going to have to factor this again. If you see something squared and something by itself and a number, you're going to have to factor it. So this would be cosecant x minus 1, cosecant x minus 2. Two numbers that multiply get positive 2, add together to get negative 3. So I solve for both of these. So I have cosecant x is equal to 1, cosecant x is equal to 2. You want to flip-flop it because that's the same thing as 1 over sine x is equal to 1, 1 over sine x is equal to 2. So I'm really dealing with sine x is equal to 1, and sine x is equal to 1/2. So you draw your picture. And I have sine, so sine again is my y value. So my y value would be here. That's where it's positive 1. And then I have all sad turtles. Opposite over hypotenuse. So this angle would be 30 degrees, 30 degrees. Now if you check in between these two angles right here, it would be 100, oh, there's the bell, 240. So those can't be partners. These also can't be partners. So I'm going to have 3 separate equations. So in this first angle, that would be pi over 6 plus 2 pi n, because again, you have to account for every single angle, no matter how many rotations you have. The second angle is pi over 2 plus every single circle. The third angle would be 5 pi over 6 plus 2 pi n. And those 3 would be my final answer. Ding, ding, dong. Question number 7. So this one looks like I have multiple angles here because I have a 2x. So I can solve for cosine 2x first. Whoopsies. Cosine squared 2x would be equal to 1/2. So cosine 2x would be equal to positive negative 1 over the square root 2, because you have to take your square root in order to get rid of that squared. So my picture would be 1 in every quadrant. Remember, when you have a plus or minus, that means you're dealing with every single quadrant available. Adjacent over your hypotenuse. Adjacent over your hypotenuse. So that means each one of these angles are 45 degrees, which are nice, because when that happens, in between these two angles, this line and this line is 90. Here it's 90, 90, and 90. That means that I can write only one equation. Only one. All I need is 1. So my first angle is pi over 4. Plus, my rotation is 90 degrees. That is pi n over 2. But remember, this is equal to 2x. So I have to multiply by 1/2 on both sides. Do not forget to multiply by everything on the inside. So my final answer would be pi over 6 plus pi n over 4 is equal to x. That's my final answer for that one. And last but not least, I'm going to move everything to one side of the equation. I'm going to subtract cotangent here. I'm going to subtract 2 here. So I have 0 is equal to, now I'm just left with 1 cotangent x plus 1. So I'm actually going to move that over. And I'm going to rewrite this as tangent x. Negative 1 reciprocal is still negative 1. So I'm looking for all my answers. Tangent negative 1. So this is all sad turtles cry. So this is where we're dealing with negative. Opposite over adjacent. Opposite over adjacent. So my angle here is 45 degrees and 45 degrees. Now one thing I notice is that I will have 180 here and I will have 180 right here. So my rotation is going to switch. So when I add on my n, so I have x is equal to my first angle that I'm dealing with. This first angle right here, that's the first angle that should be in the equation, which would be 3 pi over 4. And then my rotation in between my terminal sides is 180. That's the same thing as pi, and that one should have the n in it, because no matter how many times you rotate, it's going to be an answer. So that's all solutions. And bing, bada, boom. That is solving equations reteaching. Have a great, grand, wonderful day.